Hello again, grade 8s. In today's lesson, we're going to begin a new unit on surface area and volume of three-dimensional objects. And most of this unit is going to involve determining the surface area and volume, specifically of a right rectangular prism, a right triangular prism, and a right cylinder. We're also going to look at how to sketch different views of three-dimensional objects. However, before we do that, we're going to take a little bit of a step back to some material that you would have learned back in grade 7, dealing with a circle, specifically talking about the radius, diameter, circumference, and area of a circle. We're going to need to use this information when we start to deal with right cylinders later on in the unit. All right, so I have a quick little illustration of a circle. And I'm going to label the center of the circle with a point, and I'm going to label that point as capital M. You can think of capital M as being an abbreviation for the midpoint or the center of the circle. I don't want to use capital C because I'm going to use that variable to identify a different physical part of the circle in a moment. So we'll start off by identifying the radius, which I'm going to abbreviate with the variable that's a lowercase r. And the radius of a circle is the length of a line that is going to start at the midpoint or the center of the circle, and it's going to go to an outer edge of the circle. One such line, as you can see in the diagram, starts at the midpoint, and then it goes down and right towards the bottom right portion of the circle. That's the radius. It turns out it doesn't matter where you draw this. You could start at like the midpoint and you could go up and towards the right. Okay, as long as it's a straight line that starts in the midpoint and goes up and towards the right, we can label it as the radius of the circle. We also have the diameter of a circle, which we're going to abbreviate with a lowercase d. And the diameter is defined as the length of a line that must pass through the center of a circle and touches 2 points on the edge of the circle. So really what that's trying to say is it's a line where you start at one edge, you go to another edge across a circle. However, on the way from one side of the circle to the other, you must pass through the circle's center. So to illustrate that, for this picture, we're starting at, for example, the bottom left portion of the circle. Then we pass through the circle, going through the middle, the midpoint or the center. And then we end up in the top right-hand portion of the circle here. If you draw a line representing the diameter, it'll always cut the circle into 2 equal halves. I also want to relate the diameter and radius of a circle mathematically. It's actually really easy to identify the relationship between the two. The diameter of a circle is equal to 2 times the radius. In this equation, we don't need to write down the multiplication operator. If we just write the equation as d is equal to 2r, the multiplication operator is implied between the numerical coefficient of 2 and the radius little r. Now, it's very easy to justify why this is true. So let's go back to my picture. I'm just going to erase the radius we have here. If you take one radius starting here, and then going to the center of the circle, which I've already drawn, and then you add another one, going from the center of the circle, this time to the top left, it turns out that if you take the value of r and you just double it, you end up getting the length of what the diameter would be. So that's what the equation's telling you. It's saying is if you double the radius, you will get the length of the diameter. We also have an equation we can use to calculate the radius. So the radius would actually just be take the diameter and cut it in half. If you cut something in half, you divide it by 2. Therefore, the radius would be d over 2. Again, whenever you see that fraction symbol, it means division. Radius is diameter divided by 2. We also have the circumference, which we're going to abbreviate with a capital C. And again, this is the reason why I chose not to label the midpoint of the circle with the capital C. The circumference of a circle is defined as, I said the perimeter in italics. I don't really want to call it the perimeter. I'll clarify why in a moment, but it's the distance around the outside of the circle. So if I started with a point at the very bottom left portion of the circle here, and let's say you took a piece of string and you wrap that piece of string all the way around the outside of the circle, that would represent the circle's circumference. It's the distance around the circle on its outside one time. So I loosely define that as perimeter because typically perimeter involves a bunch of different line segments that are added together. And obviously with the circle, you don't have line segments on the outside. You just have like a curved shape. But you can think of it as perimeter. And perimeter really is just what's the total outside length of a shape equal to. And again, I just quickly illustrate that with a different circle. This one's a little bit more nicely drawn than the one that I freehand sketched. To calculate the circumference of a circle, we can use the following equation. Our equation is circumference is equal to, we have this Greek letter that's referred to as pi, and we have pi times d. And again, we don't need to write down the multiplication operator. We can just simply write down circumference is equal to pi d, where the multiplication operator is implied between pi and d. Pi is actually a number that just repeats on and on and on and on and on. It doesn't actually have any pattern to it. What we're going to do is we're going to use an approximated value of pi in all of our calculations. And the value that I want you to use is 3.14. So we'll always round it to 3.14. Some of your calculators may actually have a pi button built into it. And if you use that pi button, it'll give pi to more decimal places. In which case, if you use that pi button compared to 3.14, you're going to get some slightly different answers compared to like what I'm going to get using the value of 3.14. So just a word of caution, I would just stick to using the 3.14. Okay, so let's look at an example where we actually do this. So I want to calculate the circumference of the following circles and round to the nearest tenth if necessary. When I say if necessary, it just means if it's a whole number. There's no need to add like a decimal zero just to make it go to the nearest tenth. The first thing you want to do is before you even try to calculate this, you want to look at the picture and identify whether the diagram is showing you the diameter or the radius of a circle. Now, in this one, I have a line that starts at one edge and goes to the opposite edge, and it passes through the center of the circle, so that's my diameter. Because of that, I can just simply go and use this equation that I've identified. So we'd have circumference is equal to pi times diameter. And we'll use my three-step procedure here for showing work. So step one would be write down the equation. And then step two would be substitute in these symbols or these variables with the correct numerical values. Pi is 3.14. And it does not have any units to it. Reason being is pi is actually a ratio of the circumference of a circle to its diameter, so the units actually just cancel off. The diameter here is 12.6, and the units are centimeters. And then, if we plug this into our calculator, so I'm going to plug it in 3.14 times 12.6, I would get 39.564. If I round that to the nearest tenth of a decimal or the tenth of a centimeter, I'm going to get 39.6 centimeters. And we'll box it answer. So again, my three-step procedure is step one. You want to write down the equation. Step two, plug the numbers in with units if they have units. And then step three would be write down the correct answer, round it properly with the correct units. For B, what I see here is a line that starts at the center of the circle and goes to the outside. So it turns out that's the radius. The problem is my equation is circumference is pi times diameter, so I can't really use the equation until I calculate what the diameter is. Fortunately, it's really easy to do that because the diameter of a circle is just double the radius. So you have diameter is equal to 2 times r. So if I plug that in, it would be diameter is equal to 2 multiplied by 32.6 meters. And then I would get D is 2 times 32.6 would give you 65.2. So my diameter is just double the radius. Now that you know what the diameter is, you can use this equation to figure out the circumference. So we'd have C is equal to pi times the diameter. And then C would be equal to pi, which is 3.14. And again, pi doesn't have any units to it. Multiplied by D, which I just calculated, it's 65.2 meters. And then I would get the circumference of the circle, which is the distance around the outside of the circle, would be 3.14 times 65.2. That would give you 204.728. But if I round that to the nearest tenth of a meter, it gave me 204.7 meters. And let's go ahead and box that. The area of a circle just represents the region which is enclosed within my circle. So I've just shaded that in with red in this picture. So how much of the region is enclosed within your circle. To calculate the area of a circle, we can use the following equation. So my equation is A is equal to pi multiplied by r to the power of 2, or pi multiplied by r squared. Just as a quick reminder, anytime you have like an exponent, what that means is it tells you how many times you multiply the base by itself. So r squared would actually just be r times r. So it's repeated multiplication of the base, which is r, and you do it 2 times. Therefore, we could write down the area is equal to pi times r times r. And that's the expanded format of the equation I'm going to use when I actually solve the example in a moment here. Example 2, determine the area of the following circles and round to the nearest tenth if necessary. Here's my 2 circles. Once again, the first thing you want to do is you want to look at the picture and identify whether the picture is showing the radius or the diameter. So in part A, I have a line going from the center of the circle to an edge. That's the radius. That's good because we can actually use the equation right away because the equation for the area is written in terms of radius. So let's go to my 3-step procedure. So step 1, write the equation down. So A is equal to pi multiplied by r squared. And this would be equal to pi, let's expand it, times r times r. Step 2, let's plug the numbers in with units. I'm going to plug the numbers in brackets. So pi, we're going to write down 3.14. I don't need to write down the multiplication operator. If you have a bunch of brackets side by side, it just tells you that multiplication is the implied operation. So this would be 3.14. Then I have bracket 14.8 meters. Then another bracket 14.8 meters. If you have these 3 brackets that are side by side, it's just telling you you're going to multiply them all together. So then this would be equal to, plug it in, 3.14 times 14.8 times 14.8 would give you 687.7856. But I want to round that to the nearest tenth. So the nearest tenth would be 687.8. Now you got to be a bit careful about the units here. So if you look at the actual units, what I'm doing is I'm multiplying meters times meters together. So what you have is you have repeated multiplication of a base, which is meters, and it occurs 2 times. Therefore, if you write down the units for area, the units for area are actually going to be square meters. So you'd have area would be 687.8 square meters, or meters squared. B, what is this picture showing? Well, I'm starting at one edge, going to the other edge, and I'm passing through the center of the circle, and that's my diameter. The issue is the area equation is not written in terms of diameter, so what I need to do is I need to calculate the radius first. So I know the radius is just the diameter cut in half. R is equal to D divided by 2. So if I plug that in, I would have R is equal to 6.8 meters, and then I divide that by 2. And then I would have R is 6.8 meters divided by 2 would be 3.4 meters. And now that I have the radius, I can then use this equation to calculate the area. So I'd have area, step 1, show the work, or show the formula. So area is equal to pi r squared, and that would be equal to pi times r times r. Step 2, we're going to replace the symbols with the actual numerical values and the units if they have units. Pi is 3.14, doesn't have any units. The radius is 3.4 meters. Multiplied by another radius, 3.4 meters. And then if I plug this into my calculator, using pi is 3.14, so 3.14 times 3.4 times 3.4 would give you 36 point. Well, if you plug it in, you get 36.2984, but round to the nearest tenth, it'd be 36.3 meters squared. That's it for this review lesson on circles. So you can complete the assignment called circles in the surface area and volume workbooklet. And then the next lesson, we're going to look at how to sketch different views of 3D objects. And I will talk to you